Good afternoon, class. Let me start my presentation on network topologies. So what is topology? Well, it is the way in which the connections are made among all the computers. This is called the network of the topology. Network topology specifically refers to the physical layout of the network, especially the location of the computers and how the cable is run between them. Now, the most common types of topologies are the bus, the star, the ring, and the mesh. Bus topology. The bus is the simplest and most common type of topology. It is often used when a network installation is small, simple, or just temporary. It is a passive topology. This means that the computers on the bus only listen for the data being sent. They are not responsible for moving the data from one computer to the next. And here is an example of the bus topology. Now, the bus topology is an active topology network. The computers regenerate signals and are responsible for moving the data through the network. On the bus network, all the computers are connected to a single cable. Now, when one computer sends a signal using the cable, all the computers on the network receive the information, but only one addressee accepts it. The rest disregard the message. Now, looking at the advantages of the bus is a simple, reliable, very small network and is easy to operate. The bus requires the least amount of cable to connect the computers together and is therefore less expensive than other cabling arrangements. And also, failure of one node does not affect the rest of the network. Now, let's take a look at some of the disadvantages of the bus. Heavy network traffic can actually slow the bus considerably. A break in the cable or the lack of proper termination can bring the network down. It is difficult to troubleshoot on the bus. Looking at the appropriateness of the bus network, the network is very small, also that the network will not be frequently reconfigured, and the least expensive solution is required. Also, that the network is not expected to grow. Now, taking a look at the star topology. In the star topology, each device has a dedicated point-to-point link only to the central controller, usually called a hub, server, or host. Each computer on the star network communicates with the central hub that message appropriate computers. The hub can be active or passive. An active hub regenerates the electrical signal and sends it to all the computers connected to it. This type of hub is often called a multi-port repeater. Active hub require electrical power to run. A passive hub, such as wiring panels, merely acts as a connection point and does not amplify or regenerate the signal. Passive hubs do not require electrical power to run. And here's an example of the star topology with the server, hub, and 4 computers. Now that we've seen an example of the star, let's take a look at some of the advantage of the star. It's easy to modify and to add new computers to the star network. During adding or deleting a node on the network, it can remain to function normally. When the capacity of the central hub is exceeded, it can be replaced with one that has a larger number of ports to plug lines into. It can provide centralized monitoring and management of the network. A single computer failure does not necessarily bring down the whole star network. Now that we've seen the advantages, let's take a look at the disadvantages of the star. If the central hub fails, the whole network fails to operate. It costs more to cable the star network, and it also requires a dedicated server and a network operating system, or a NOS. The appropriateness of the star: it must be easy to add or remove client computer. It must be easy to troubleshoot. The network is large, and the network is expected to grow in the future. Moving on to the ring topology. In a ring topology, each computer is connected directly to the next computer in line, forming a circle of cable. It uses token to pass the information from one computer to another. Each computer is connected to the next computer in the ring, and each retransmits what it receives from the previous computer. The messages flow around the ring in one direction. Also, the ring is an active topology. There is no termination because there is no end to the ring. And here we have an example of the ring with 5 computers, and you see the circle in which the cable would go. Which brings us to token passing. Token passing is a method of sending data in a ring topology. Now, a small packet called a token is passed around the ring to each computer in sequence. If a computer has information to send, it modifies the token, adds address information and the data, and sends it down the ring. The information travels around the ring until it either reaches its destination or returns back to the sender. A token can circle a ring 200 meters in diameter and about 10,000 times a second. Which brings us to the advantages of the ring topology. All the computers have equal access to the network. Even with a heavy load of users, network performance is even. And the ring also allows error checking and also acknowledgement. And then we have the disadvantages of the ring. Failure of one computer can affect the whole network. It is also difficult to troubleshoot on the ring. And adding and removing computers disrupts the network. So looking at the appropriateness of the ring, the network must operate reasonably under a heavy load. A higher speed network is required, and the network will not be frequently reconfigured. And now moving on to the mesh topology. In the mesh topology, every device has a dedicated point-to-point link to every other device. A fully connected mesh network therefore has physical channels to link together devices. And to accommodate that many links, every device on the network must have an N-1 input-output port. And now taking a look at an example of a mesh topology. You have the 5 computers and the connections between them all. And taking a look at the advantages of the mesh, because of the dedicated link, no traffic between computers. Failure of one computer does not affect the rest of the network. Because of the dedicated link, privacy and security is guaranteed. Point-to-point links make fault identification and fault isolation easy. And then looking at the disadvantages of the mesh, due to the amount of cabling and number of input-output ports, a mesh topology is very expensive. It requires more cabling than other LAN topologies, and it is very complicated to implement. And the arrangement of the network node is connected to every other node of the network. Many of the connections serve no major purpose. This leads to the redundancy of many of the network connections.